if we are talking about our systems, a few words you might hear me say. The solution is the ordered pair that makes both true. So if I'm asking you to find the solution, I'm asking you to find the point that makes both true. If it has a solution, we call it consistent. You have two different equations, independent equations. If it doesn't have a solution, it's inconsistent. And if it has infinite solutions, it's consistent because we got a solution, but they are dependent. So when we're solving these, there's three options. Either you are going to get, if we're talking about linear systems, so lines, you will get a single solution. So if you have two lines that meet, that's called consistent. You have independent equations, okay? Two lines can only meet in one point. If you solve it and you get infinite solutions, that means both equations had to be for the same line. And so that's still considered consistent because we got an answer, but because it's everything on the line, those are dependent because they are equations for the same thing. What would it look like to be inconsistent? Parallel lines, two lines that never touch. And so no solution, we call that inconsistent. To solve these, you have done them in the past using three different options: graphing, substitution, and elimination. We aren't going to use graphing for these just because, if you remember, your lines had to be perfect to find the point where they met. If you got off slightly, it threw off your answer. So we're just going to eliminate the possibility of error and stick with things that are a little more concrete. So we're going to use substitution and elimination to do those. So let's take a look. If I told you to solve this using substitution, do you guys remember what substitution meant? Yes. You pick one equation and solve for one variable. There is no right or wrong here. So let's say I wanted to solve for y, or solve for x in the second equation. So if I wanted to get x by itself, I would add over my y. So I know x is 4 plus y. I am going to substitute that into the first equation because I haven't used it yet. So the first equation, I had x, which is 4 plus y, plus y equals 8. Does everyone see what I did there? Now this is an easy equation to solve. So we have 4 plus 2y equals 8. So 2y is equal to 4, which means y is 2. How do I find x? Substitute it back. I know x is 4 plus y. So if y is 2, 4 plus 2 is 6. I do want an ordered pair at the end, x, y. So my answer is 6, 2. And it's very easy to check. 6 plus 2 is equal to 8. 6 minus 2 is equal to 4. So I know I got the right answer. All right, let's try another one. So I told you there's no right or wrong in substituting. We pick one equation and solve for one variable. We can do any of them, but sometimes there is an easier option. What would be the easiest thing to get by itself? The y in the first one. that'll help me eliminate fractions. So you certainly don't have to do that, but if I see an easy option, might as well go for it. So y is 5 minus 2x. Then I'm going to substitute that into the other equation. So I'm going to plug it into the second one. So we have negative 4x plus 6 times y, but what is y? So we can solve negative 4x. Plus 30 minus 4x equals negative 2. Combine like terms. Subtract over my 30 and divide, then x is 2. Plug that back in to get your y. So y is 5 minus 2 times x, which is 2. And we get 1. So our answer is 2, 1. And like before, we can always check if I plug it in. 2 times 2 plus 1 is 5. Okay, 4 times 2 plus 6 times 1 is negative 10. Okay. Do we remember substitution? Let's try elimination. So, in elimination, you want to be able to add your equations together and cancel out a variable. Now, if I just add them right now, does anything cancel out? No. So, to fix that, we had to multiply by something first. Things will cancel if they're the same coefficient but opposite signs. You need a positive and a negative. So, you pick, does it matter if I cancel out x or y? No. Let's say I want to cancel x. What would I have to multiply by? 1x, I could take the first one times 2. If I were trying to cancel y, what would I multiply by? Negative 6, so our signs would be opposite. All right. So I have 4x plus 2y equals 10. I didn't change the second equation, although sometimes you might have to multiply both of them by something, and that's fine. Now we add them together. So 4x plus negative 4x cancels. 2y plus 6y is 8y. 10 plus 12 is 22. Divide by 8, and we get 11/4. We can have fractions on these, so that's not alarming. In this, how do I now find my x? Plug it back in. Either equation, so if I go with the first one, 2x plus y, which was 11/4 equals 5. So if I subtract over my 11/4, divide by 2, x is 9/8. So we get 9/8, 11/4 for our answer. So far, so good? Let's look at this one. What should I do? Multiply by -2 if we want opposite signs. Okay, so that gives me a -4x minus 2y equals -10. And a positive 4x plus 2y equals 8. When I add those together, those cancel and those cancel. So all I'm left with is 0 equals -2. Is that true? No. So it's no solution. I am also going to ask that when you get a no solution, you call it inconsistent. So usually, like on test or quiz, my directions will say label any inconsistent systems. So the answer is no solution. The type of system then is inconsistent. So what's that mean about those two lines? They're parallel lines. Good. They do not cross. All right. Let's look at another one. Don't let the fraction confuse you, it's the same thing. Let's say I wanted to cancel x. What would I have to multiply by to turn 1/3 into a 6? You can get it by dividing them, 6 divided by 1/3, or you can think I'd have to multiply it by 3 to turn it into a 1, and then a 6 to get a 6. So 3 times 6 is 18. So we get 6x plus 3y equals 12. And we have 6x minus 3y equals -12. When I add those, my positive and negative 6x cancel, positive and negative 3y cancel. So I get 0 equals 12 plus -12, 0. What does that mean? It's consistent, means they are the same line, right? 0 is equal to 0. Now this is probably the one piece that's a little bit different. In the past, you probably just wrote infinite solutions and went on. But we're not trying to say that every single ordered pair works, right? It's only the ordered pairs that fall on the line. So there are infinite solutions, but it's only the ones on the line. So we are going to be asked to describe those a little bit more. Your directions will say, if the system has infinite solutions, write the set with y arbitrary. Okay, it could ask for x or y, but that's saying how it wants you to write your solutions. We know we're looking for an ordered pair, x, y. If it says y arbitrary, we're going to keep it in terms of y. So y stays normal. We have to find an equation for x. So we're just going to take one of these two, so I'll just go with the second one, and I want you to solve for x. So if I were trying to get x by itself, I would add over my 3y, and then divide by -6. So x is 2 minus 1/2 y. And that's what we write in the ordered pair. So it's basically giving yourself a formula for how you would find the points. If I tell you to keep y arbitrary, that means you keep the variable y. If I said x arbitrary, you would keep x and you would solve for y. So you're just describing the points on the line. Is that one okay? Let's try one on our own and see how we do. Alright, so if we multiply first one by -2, so we get -2x minus 4y equals -8, and positive 2x plus 4y equals 8, we get 0 equals 0. So we know there's infinite solutions. If I ask you to write it with y arbitrary, that means you keep y, you need to solve for x. So can you use either equation? The first is probably the easiest, because all you have to do is subtract your 2y. So it's 4 minus 2y, y. Is that okay? Good. Next thing. So this was basically section 5.1. Section 5.5 is doing the same thing, but with nonlinear systems. And nonlinear systems means at least one of your equations is not a line. So we don't necessarily know how many intersection points we're going to have starting. It just kind of depends on the scenario. For instance, if I were giving you like a parabola and a line, is it possible for a parabola and a line to never cross? Yeah. Is it possible for them to touch once? Yep, I could have something where they touch once. Is it possible for them to touch twice? Yes. So I might have 0, 1, or 2 solutions in that case. If I were looking at 2 parabolas, I might have multiple intersection points. So it just depends on the equations themselves, how many solutions you'll get, but the process is the same, substitution or elimination. What would easily be eliminated here? The y. I don't even have to do anything. And we would want to get rid of the y because we have x and x squared. So we want to keep x, get rid of y. So I can't add x squared and x, so I just keep it as x squared plus x equals 2. I subtract my 2. What multiplies to -2 and adds to positive 1?
2 times -1.
So we get x to be a -2 and a positive 1. That means we have 2 points. You have to get y for both of them. So to do that, you just plug your x into one of the equations. Doesn't matter which one. If I go with the second one. So if I add my 2 over, I just get y equals 0. -2, 0 is a point. If I plug in my 1, I subtract that over, I get my y to be -3. So we have 2 points, -2, 0, and 1, -3. And again, you can check those, you plug them in for both equations. Both points make both equations true. All right. Is that one okay? Why don't you guys try this one? So we get 3x squared, positive and negative y squared cancel, equals 12. Divide by 3, so x squared is 4. Get rid of the square root, square root. Anytime you add a square root, you also need, so x could be positive or -2. All right. So if x is 2, you get 4 plus y squared equals 4. So y squared is 0, so that means y equals 0. Now, if it had been like y squared equals 1, then you would have y equals plus and minus 1, so that would have given us 4 points. You would have had like 2, 1, and 2, -1 there. What happens when I plug in -2? You also get the same thing because -2 squared is also 4. So we got 2 points, 2, 0, and negative 2, 0. Is that one okay? Let's do one final problem. All right, can I just add these together and get something to cancel? No, so what do we do instead?
Multiply the top by -3.
Okay. So if we add these together, we get x squared plus cancel equals -4. And I square root, what's the square root of -4?
2i.
We can have that, so 2i is a point and -2i. So now I have to plug those back in. So if I did it in the first one. What is 2i squared? Close. -4, right? Because it would be 4i squared. So if I add my 4 over, I get y squared equals 9. When I square root, that gets a plus or minus, so I get y could be positive or -3. So when x is 2i, I got two different answers. That means we have more points. We have 2i, 3, and we have 2i, -3. Alright, what happens if I put in a -2i? Yep, when I square that, it's 4i squared, which is -4. So y squared is 9. So I again get plus or minus 3. So this time we got 4 points. Are there any questions? Okay, so two things. Your homework is a handout on Google Classroom, so you can start working on that now. Tomorrow, I am going to be gone for a conference. So we're going to switch things. There's a little bit more to this section, but I'm going to wait and do that next week. Tomorrow when you come in, if you look on Classroom, there'll be a video for graphing systems of inequalities. So you might remember that from last year. If not, you'll probably get it as soon as you watch a few minutes of the video. But the sub will have a handout, and she should give you an actual physical copy of the handout. So ask for that if she doesn't. So you can watch that video and do the handout. It should be an easy one to do without me.